Hey guys, Mr. Zigner, thanks for joining me for a look at using similar triangles. All right, so first of all, similar. What does similar mean in geometry, in mathematics? It's two shapes that have the same shape, but not necessarily the same size. All right, moving on. Let me move my picture out of the way here. So, angles of similar triangles. All right, so we have our two similar looking triangles here. When two angles in one of the triangles are congruent to two angles in the other triangle, well, then the triangles are similar. Because here's why. Automatically, if two angles are the same, then the third one is also going to be congruent. And you can see here 20 and 20. So they already had 95 and 65 in common, but guaranteed that third angle is also going to be the same. And here's how we write that similarity. Here's triangle ABC. That's the symbol for similar, similar to triangle DEF. Okay, moving on. All right, so tell whether these triangles are similar and explain. All righty, so we'll look at this first one here. All right, so first of all, I'm noticing they have a 122-degree angle in common. All right, great. They already have one angle in common, but we need to prove if a second one is. So one way is to figure out this third missing angle. So every triangle adds up to 180 degrees. So let's see what this third angle here would be. So first of all, 122 plus this 28. 8 and 2 is 10. 2, 4, 5, and 150. Okay, so right now this triangle's two angles add up to 150. But like I said, every triangle is 180 degrees. So 180 take away 150 leaves you, well, 30 degrees. Okay, so this angle right here is 30. All right, do we have two angles in common between these two triangles? Well, yeah, sure we do. We have a 122 and a 30 here, and there's a 122 and a 30 here. So you would say, yes, yes, these triangles are similar. Why? Because they share two angles in common. And guaranteed, if we figure out this third angle on the other triangle, it will also be 28. But all we have to do is say that the two angles are the same, and we're done and ready to move on. Okay, let's look at this one. Alrighty. So they look similar, the shape of them, and they already have a 20 in common. What we have to do is prove either if this one right here is 65 to match this one, or if this one's 105 to match this one. All right, so here we go. Let's work on this first triangle. So the first one is 105 plus the 20. Oops, my plus sign got messed up there. So that's 125. All righty. So again, triangles add up to 180. Take away the 125. And let's regroup. So that's a 7. That's a 10. 5. 7 minus 2 is 5. So it looks like our third angle in the first triangle is 55. Oh, guess what? Those are different. So this is a no, and they don't share two angles in common. All righty, moving on. Oh, I like indirect measurement. It can sort of like do this sort of a thing on a sunny day outside. If you took something outside you knew the height of, like a yardstick is 3 feet long, and it cast a 6 foot shadow, then you should be able to find the height of something that's very difficult to measure directly. So here's what I mean. So the 3 foot yardstick, I'm going to make a proportion here, makes a 6 foot shadow. So there's my first ratio, and it's equal to, oh, but here's the thing we don't know. We don't know its actual height over its 24 rather, foot shadow. All right, let's solve this. So, well, 3/6 is 1/2. Okay, so 1 is half of 2. Oh, and 3 was half of 6. So what number is half of 24? Yep, 12. So it looks like this tree is 12 feet tall. And look at that. You set up a quick proportion, and you can quickly find the length of a missing number, usually like a tall building or a tree, something that's hard to measure directly. Oh, okay, here we go. They're going to give one just like that. Now, you can only do this when you have two similar triangles. Do you see the two similar triangles? Right here, this little one, and then the big one. Okay. Now, why are they similar? They have to have two angles in common. Do you see them? Well, they each have a 90-degree angle. And do you see the second angle they have in common? It's right here. They actually share right here. They share this angle C. The big triangle has angle C and the little triangle has angle C. So they have their two angles in common. Okay, so we can now treat them like similar triangles. So we can set up our proportion. So, okay, we've got 4 over 6. So a height of 4 for the person over 6 foot is going to be equal to the height of the tree. That's the thing we don't know over this distance. So 9 plus 6. 9 plus 6 is 15. So over 15. Now, can I simplify this a little bit? Oh, how about this? 4 over 6 can come down to 2 over 3. That's the simplified version of it. Now, what could I do? How about, cross products? So 3x is going to be equal to 2 times 15. And 2 times 15 is 30. Okay, divide by 3, and we find out that x equals 10. So our height of our tree is 10 feet. There we go. So again, creating our two ratios, making them equal to each other. We can only do that when we have similar triangles. And then we solve for the missing amount. Okay, moving on. So this is all based on the whole distance across the river. You'll see some of these when you get to high school. Now, do you see how these two are similar triangles? So we're trying to find the distance across the river. Of course, we have to be careful of any dangerous creatures we might run into. But how far is it across our river here? So what you do is you make some measurements on the side of the river that you're on currently. So we march out, we find this distance is 16. Keep continuing down a little bit further for 8 more meters. And then they come back 7 meters. Now, the reason for that is they want to look across the river at the same point they were looking at when they were standing here. So by doing this quick measurement, getting these 3 numbers, you can actually create 2 similar triangles. Now, again, they're similar because they have to have 2 angles in common. Do you see the 2 angles that they have in common? I'll show you. Well, right here and right here are right angles. There's the first one. Do you see the second one? They're right here. These are called vertical angles, and we discussed this in another video. Vertical angles are created when you have 2 lines that intersect each other, and the angles that are opposite of each other are called vertical angles, and they're congruent. Okay, so now that we know we have 2 angles in common, these are similar triangles, and we can just create a proportion. Let's see here. This 8 corresponds to this 16, so 8 over 16 equals, okay, so again, this triangle is a smaller one, so I put the smaller number on top. This 7 over, okay, this height right here would be corresponding to this one across the river, so that would be x. Now, let's see, what can we do to solve this? Oh, well, once again, 8 over 16 is 1/2. Sure, because 8 is half of 16. So what is 7 half of? Well, that would be 14. So it looks like it's 14 meters to get across the river, but you better swim fast or you might run into trouble. Okay, moving on. All right, so for these, I think I'm going to move myself over on this side. Hopefully that'll work. And let's look at some of these evens. Now, once again, we're looking at are the triangles similar? So what do we have in common so far? Okay, well, they both have 41s. We have one angle, but we need a second one. So let's figure out what the extra angle would be. Let's go with this one right here. So 41 plus the 74 is going to equal, well, that's a 5, 7, 8, 9, 10, 11. All right, so far we have 115 degrees, but again, every triangle is 180 minus the 115. Regroup, 7 and a 10, so 5. 7 minus 1 is 6. Okay, so it looks like angle X is 65 degrees. Oh, and that has a 65-degree angle. So do we have 2 angles in common? Sure. 41 and 65, 41 and 65. So we would say yes. And our explanation would be, well, both triangles contain a 41 and a 65-degree angle. So as soon as you have 2 angles in common, you're allowed to say that the triangles are similar. Okay. And I'm looking at the even, so we'll skip that one. Uh-oh, my picture is on top of the words. So let's come up here. All righty. So you can use, so this is another version of the shadow with the tree or the distance across the water. Let's take a look here. So you can use indirect measurement to estimate the height of a building. Right, that would be very difficult to measure. First, measure the distance from the base of the building and a distance from the ground to a point on the building that you're looking at. Wow, that was quite a mouthful. Let me explain what they're talking about. So here we are standing, and we are 7 feet away from the building. Also, we're looking at it from a height of, let's see, the person's about 5 feet tall, and they said up to here was 10 feet. So it looks like this person's about 5 feet tall. Oh, right here it says 5 feet tall. Sure. Okay. And now you maintain the same angle of sight. Okay. So in other words, you don't tilt, you leave your head tilted in the same angle. And now you move back until you're looking now at the top of the building. Kind of a weird way of doing it. It's not my favorite way of doing it. I think you could really run into some error there because you might tilt your head a little bit as you're trying to do it. But whatever, we'll solve our problem first. Okay, explain why ABC and DBE are similar. Okay, well, here's ABC, this little triangle, and is it similar to DBE? Well, sure it is. First of all, we have to prove they have two angles in common. Well, they both share angle B, so they have angle B in common, but they have to have another angle in common. Do you see what that one would be? It turns out that angle A here, right here, in this triangle, would be congruent to angle D down here. Now, the reason why, they kind of mentioned something that kind of proves these two are definitely the same measure. It was right back, let me see if I can find it. Here it is, maintaining the same angle of sight. So, however you have your head tilted back as you look up at the building, you kept your head the same. So, your head is still tilted looking up at the same angle. So, there we go. We have two angles in common. All right. So, let me just erase all that. Explain why ABC and DB are similar. Well, they share, the two triangles would share angle B. And we just said that angle A is congruent, there's our symbol for congruent, to angle D. Now, I mean, I could go into, I don't have much room here, but I could go into explaining why they're the same, because the person kept their head at the same angle of sight. But I want to get through this video a little bit faster and not have it last too long. So what's left? What's the height of the building? Okay. All right. So let's figure out the height of this building. So we could set up our ratios. So right here, from from 7 feet away, we're looking at 10 feet high. So from 5 feet away, from 7 feet away. My bad. Where's my eraser? From 7 feet away, okay, we're looking at 10 feet high. And now we're 42 feet away. From 42 feet away, the building is, well, we don't know. We don't know the height. Okay. So does someone see a way of getting this x quickly without having to do our cross products? I see something. Do you see it? It's right here. 7 times what is 42? Well, it's times 6. 7 times 6 is 42. So I don't know if you've seen this one before, but whatever you do, in this case, multiply to the numerator, if you multiply the numerator by 6, if you also multiply your denominator by 6, you create an equivalent fraction. So 10 times 6 is 60. There we go. So this building is 60 feet tall. All right, super. Moving on. Okay, that's an odd. I'm going to look at the evens. Okay, so now this is an even, but I did pick this one out. I wanted to look at one more of these to make sure you understood. Explain why VWX and YZX are similar. Well, VWX and YZX, they are similar. First of all, do you see it? They have that shared vertical angle. So these vertical angles are congruent, and they also both have 90-degree angles. So there we go. We've proven they have two angles they have in common. So therefore, VWX and YZX are similar. Okay. The second part is how far is it across the swamp? This distance of L. All right. So let's see here. Um, well, let's see. The short distance right here of 30 would correspond to this shorter side of this triangle of 60. So we set up our first ratio, 30 over 60. Now that's going to equal the short distance across the swamp. They used a cursive L over the longer distance here, the other leg of these right triangles. All right, so that was 100. Okay. Oh, look, 30 over 60 once again is 1/2. Okay, because 30 is half of 60. So what number is half of 100? Well, you can pretty quickly arrive at that being 50, 50 feet. Okay, so that's the distance across our swamp. Well, thanks for joining me again, and I hope you found that helpful. Tune in next time, and we'll be looking at more similar shapes. But for now, have a great day, and thanks for joining me. Bye bye.